Well, hello. So this week is going to be Lab 10, and this will be essentially the last 2D assignment you'll be doing in this class. We're going to continue to build upon the idea of doing developments, but each of these will have their own method to do essentially, and they're pretty intense, so, go ahead and start flipping through these. The ones that say, developing and triangulation and stuff, those are all resources, so I have each of these open, and then you'll have two videos in the drawing developments areas here. So I've already opened each, and then you'll have the 3 assignments. So I'm just going to flip through and talk about them because I had to make a video essentially for each of these. So, you've got a lot of resources, and I don't want to overwhelm you. So the idea is for the first 2 assignments, this one and this one, you will be using the method shown in the drawing developments of transition planes or pyramids video, which is essentially using this resource and as well as this one. Now I do talk about those in the video pretty in depth, so I'll just give a brief rundown just in case you missed that concept. The idea is essentially when you're making a development, because everything is shown in a oblique face area so you cannot get true to size values, use this very peculiar method of drawing from the origin a circle, and from that circle projecting down, and then from the origin, which is the same position everywhere, you would draw from there to where that point meets the bottom where the face itself is. So because 1, 4, 2, and 3 are on the bottom, when you project down, you're projecting to where they meet down here. So from there, that gives you the true to size value of O1 prime, which is the same as, ostensibly what you're looking at O1 when not true to size, but this is the actual true to size length, which is why they put prime in front of it, or behind it. So then, basically I go through and show how to go about this, and honestly, if you're not watching a video on this, there's no way you can get it right, but, that's the general idea with those. So, one thing I do want to mention that I did fail to do in the video, I drew this one, but the concept can be applied here. It's actually a simplified version because on this one, you don't have that cutoff, and 2, your axis is in the middle, your origin. So you'll be able to take the same method I did for this one and pretty easily transfer and do the other one. But I did fail to do, now I just chose a random point in this video, but I did fail to change the interior fold lines to be fold. So take note, I still want you to do that. I just, I forgot to do that in the video. So then we're going to do one more assignment, which is this bad boy. So as you can see, it's a conical shape with the top cut off. And naturally, since it's conical, you can't do your normal process. And that's where triangulation comes in. And it's kind of hard to explain, honestly. Even when you're looking at it, it's pretty wild in the video, because you end up with this shape, and you can see all these little circles that are everywhere. But the idea is basically you subdivide the bottom face into pieces, and then you draw circles to each one of those. And again, project down, and where that area meets, you draw a line and connect it, and that's your true length size. Now naturally, you could go and use those lines and try to make this, but it's hard. So I show a little more user-friendly way to go about it using circles, and it works out better. It's usually quicker. So same deal. You're going to have to watch the video, but I also missed something in this one. When you're doing such crazy concepts, it's pretty easy to forget a step. Make sure you have your top and bottom face. In the video, I forgot to add them, but obviously your top and bottom face are in your top view. You got your top face there, and you can just complete your edge there to make the bottom face. And then, essentially you just need to go and attach them in anywhere. Because it's a circle, it's going to be kind of weird and not look right, but as long as, essentially your quadrant is touching one of these and there's no overlap, no edges overlapping anywhere, then it'll work. And naturally, to go along with, what you're looking at, the idea is the same as other developments. If you were to take this and take it and fold it, it would equal this part here. Or if you unfolded this and folded it, or if you unfolded it and looked at this, it would look exactly like that. Now, technically, This does come out with like some weird edges, but if you were to go and print this, you would see it's close enough. This is like another limitation of AutoCAD versus, you know, a 3D program. And those you can do a little more. So, you know, this is the most accurate way to represent a development, essentially. But yeah, that's going to be it. You know, make sure you're doing your discussion board. And I know this is a very complicated series of assignments, so if you're having any questions about anything, just let me know.